This is Unit 4, Objective 4A, Rules of Probability. So we have two rules of probability. They are going to come up a lot, so I'm going to highlight them here. You have the first rule, which says 0 is less than or equal to each probability of an event is less than or equal to 1. So what this is saying is every outcome has a probability between 0 and 1. So we can't have, and remember this is decimal, we're talking about decimal, so it's 0% to 100%. We can't have any probability more than 100% because 100% means it will happen every time. We can't have a probability less than 0% because 0% means it will never happen. So every outcome has to be between 0 and 100%. And then the second one is the sum. Remember, the capital sigma means sum. The sum of the probabilities always equals 1. Sum of the probabilities equals 1. I'll write the number, which remember that's decimal, so this is 100%. If you add up all the percentages, they have to equal 100%. So the sum of all the probabilities of every single outcome, if you find every outcome and you add them up, all the probabilities, it has to be 100%. So example 1, we have 3 possible outcomes. We're just calling them A1, A2, and A3. If A1 has 20%, A2 has 50%. If you add those up, you'd get 70%. So that means if we know these probabilities, it has to be between 0% and 100%, and it has to make it equal 100%. So the probability of the third outcome, A3, has to be 30%. That's the answer because it has to add up to 100%. Okay? And then we can understand these probabilities and do what we did last time, right, with the tree diagram. So what if I flipped 3 coins? Okay, so we're going to make a tree diagram with 3 coin flips. So I'm going to make this first one, pretty big branch, heads, tails. Then we have heads, tails, heads, tails for the next branch. So remember, each branch represents 1 coin flip. So this is the first coin flip, heads or tails. The second coin flip, regardless of what I got in the first coin, I can get heads or tails. So I branch off from each one. And then finally, the third coin flip, from each one of those options, I branch off heads or tails again, because regardless of what I got with the first or the second coin flip, I still have heads or tails. So first coin flip, second coin flip, third coin flip. Notice each flip occurs exponentially. Okay, we could write out every single one, but we need to just answer this question. What is the probability of getting exactly 2 tails? So I follow this. I have heads, heads, and heads. There's no tails there, so that doesn't work. Heads, heads, and tails. That's only 1 tail, so that doesn't work. Heads, tails, heads. That's only 1 tails. Heads, tails, tails. So that is exactly 2 tails, so that one works. Tails, heads, heads. Only 1 tails. Tails, heads, tails. That one is a second outcome that has exactly 2 tails. Tails, tails, heads. That one also has exactly 2 tails. And then tails, tails, tails. That has too many now. It's 3 tails. Okay, so notice how I'm using these branches. You need to understand it. Heads, heads, heads. That's first coin heads, second coin heads, third coin heads. Then heads, heads, tails. First heads, second heads, third tails, and so on. Notice how I'm using this. Okay, so I have 3 options. Heads, tails, tails. Tails, heads, tails. And tails, tails, heads. Those are my 3 options, and then we count the total number 1, 2, 3, 4, 5, 6, 7, 8. I have 8 options. 3 of them are what we're looking for, so 3 out of 8. I could get the percentage or whatever if I want, but remember, every answer can be either a fraction, a decimal, or a percent. Okay, so that's dealing with the probability. Next is the complement. The complement is the probability of a defined event not happening. That is a key phrase right there. This is when it does not happen. So if we have some sort of event, the complement is the opposite, basically. So if you have event A, notice the, I'm going to actually highlight this in blue so you remember. This is the variables here, P of A, that is the probability, capital P represents probability, and then the event in the middle. So event A, we haven't defined it specifically yet, but then we have the complement. Notice the difference here. I'll use actually different colors so it's more clear. Okay, this is the event not happening. This is the complement, the opposite, and it's just a bar. So the probability of A bar. Okay, and the thing is, with a complement, this is the key thing here. They are exact opposites. So if one happens, the other does not. The other happens, the first one does not. Okay, so we can't interchange these things at all. They are just complete opposites. That means whatever the probability of one, the opposite probability, they add up to 1 always. So find the complement. All right, so it's the opposite. So a lot of people get confused. Usually people can understand if I had rolling a 6, the opposite is not rolling a 6. So I'm kind of throwing in a little loop. What if my probability, my event is not rolling a 6? Well, the opposite is rolling a 6. Okay, which if you know from a die, if I roll the 6, it's a 1/6 chance. All right, 1 out of 6 outcomes. And notice these add up to 1. 5/6 plus 1/6 is 6/6 or 1. Okay, so that's always true. All right, so what is, we don't really know what we're talking about in this question, but if I had the probability of not defective equaling 40%, I know the complement. It's the opposite, which is being defective. And I also can figure out the percentage because I know the complement always adds up to 100%, so it must be 56%. 56 plus 44 makes 100%. Notice you're dealing with fractions, sometimes you're dealing with decimals, sometimes you're dealing with percentages. Okay, and so we have the opposite. The complement of defective is not defective, and the complement of not defective is defective, just the opposite. Okay? So it's very simple there, but that is complements. Last, we're going to talk about odds. So the odds for an event. The odds for event A are A to B. Odds for, I'll use a different color just to clarify. Odds for A to B. Odds against is flipped, B to A. Okay, so then we also have probabilities. Probabilities and odds are different. This is how you convert. I'm going to even write it out. Probabilities and odds are different. A lot of people want to just give me the probability and say it's the odds. They are not the same. To understand this, if you want to calculate the probability, you would take the A, notice odds are A to B, the A and divide by A plus B. So if your odds were, for instance, 3 to 7, the probability for it is 3 over 10. Add them up. 3 plus 7 is 10, so 3 over 10. The odds against, which is the complement, that's why it has that, is the other one, B to A. So B is 7 over 10. And notice they're complements, so 3 over 10 plus 7 over 10 makes 10 out of 10. So if you actually looked up the odds, it might be different this year, but this was a couple years ago. The Cleveland Browns are 1 to 500 to win the Super Bowl. So those are my odds. They are not the probability, they are the odds. These are odds for. The odds for Cleveland Browns winning the Super Bowl are 1 to 500. The odds against, then, are the opposite. You just flip the numbers, 500 to 1. It's not very complicated. Odds against versus odds for, you just change the order of the numbers. Okay, if it's odds for, the first number is the number for that event to occur. Okay, if it's odds against, the first number is the number against that thing occurring. So 500 relates to every other team in the NFL winning the Super Bowl. The 1 relates to the Cleveland Browns winning the Super Bowl. Okay, and if you looked up other teams you'd notice a similar trend, and they're actually pretty low for any team. But we could also find the probability, which is different. A lot of people misunderstand that. It is different. So if we did this, we'd be 1, right? We're using the original odds here because that's the odds for them winning. So 1 divided by the sum of them. So 1 over 501 is the probability, which we can then divide, and you get 0.2%. Based on those odds, the Browns have 0.2% of winning the Super Bowl. Not Browns, 500 divided by 500 plus 1, which is 500 over 501, which we can divide, and we get 99.8%, which notice is a complement. I could have just actually subtracted from 100 and gotten the same answer. Okay? So we can have some random event odds against now, so be careful of that. You got to pay attention. These are odds against event B occurring. So event B occurring is actually more likely to occur than not. This is a typo. This should be odds for. So the first question, odds for, we need to flip it. 6 to 5. Okay. 6 to 5. That's the odds for. So notice the number first is actually the thing for odds for. The number first is the likelihood of the thing occurring. So if this one's bigger, it's actually more than half likely to occur. So when I find my probability, a lot of people want to just divide 6 over 5 or 5 over 6, which is incorrect. Remember, the probability and odds are different. So the odds for this occurring are 6 to 5. So the probability that event B occurs is 6 divided by 6 plus 5, 6 over 11, which is 54.5%. So even though that number is bigger, it's still not a super high probability, right? It's 54.5% or probability that it'll happen with 6 to 5 odds for it happening. Okay. So you have actually 3 things we talked about. We have the rules of probability, the complement, and the odds. Pretty easy to write a 3-sentence summary, so write your summary.